Hello, my name is Doug Cafoe. I'm the Vice President of Business and Market Development for Fomo Products Incorporated. And today we're going to be talking about weatherization using low-pressure polyurethane foam. First off, who is Fomo Products? Fomo Products is a manufacturer of low-pressure polyurethane foams since 1975. We manufacture brands under Handy Foam, Handy Flow, Handy Seal, and Handy Stick. We've been located in Akron, Ohio area, and our products are for professional use only. The agenda for today's discussion is going to be focusing on a few items. First off, building science basics. What is weatherization? Why weatherize? Common weatherization applications, and safety during application. Starting out with some basics, if you look at a home and how it leaks, 25% of leakage comes through the roof, 10% through the windows, 15% from drafts, 15% into the ground, and 35% through the walls. Basically, a home leaks in just about every area of the house. Common causes of air leakage. I want to start out with one of the more common causes, which would be in colder conditions, and that's where you tend to find greater air leakage. Typically, air will be infiltrated in through the lower portion of the house, often through the basement and through rim joists. That air will then migrate up out of the house through the attic floor, through all the penetrations, and that would be the exfiltration. So what you see is an actual effect that we call the stack effect, and this stack effect is much more dramatic if you have colder temperatures and if your building height is larger. So you'll have a much greater stack effect on a two-story house than you would on a ranch-style house. The neutral pressure plane is actually the difference where you have infiltration coming in and exfiltration escaping. It would be the point where that shift happens. The goal when you're talking about any home and addressing air leakage is that you want to try to neutralize the pressure plane. You don't want to change it. It's like any system, any house can have an effect. If you change one portion of it, it can affect the other portion of the home. So understanding where the neutral pressure plane is within the house is pretty critical to understanding how to address the air leakage. Now, if you're talking about warmer climates, you still have air leakage, albeit not as at great of an effect as you do in the colder climates. In this case, you would have infiltration coming in from the top of the house. Perfect example of this is if you're in a hot climate, or even if you're in a cold climate during the summertime and the second floor of the house is warmer than the basement of the house, that typically means that you're having air leakage coming in from the outside. The warm air is finding its way through the attic, through the small penetrations in the attic, into your second floor. And then that is now exfiltrating out through the bottom of the house. So what's happening is that air, warm air, is pushing the cold air down into the basement and it's escaping out. That's why your basement feels colder and your second floor feels warmer. So this would actually be a stack effect, but in a reverse format. Some causes, another cause of air leakage, it would be called the wind effect. In this case, you would actually have wind. It could be as much as simple as 20 miles per hour blowing against the side of the house. That wind is now, as it's hitting your house, it's finding its way around the house. And as it's finding its way around the house, just like wind would find its way around an airplane wing, that is then pulling air out from the other side of the house. That effect is creating air leakage. In this case, you would feel the air leakage coming from your electrical outlets. You could find it coming from out of your windows. The combination of wind and stack effect could be happening if you've got a very windy day on cold temperatures as well. When you're looking at the building envelope, the goal to determine if you have a solid envelope with minimal air leakage is, can you take your pen and can you draw a consistent line through the outside of the building without picking up your pen, meaning that all building materials have been joined together, all holes have been filled. And if you look at the common areas where there are problems within the building envelope, where you do have breaks, it would typically be in areas where you have adjoining building materials. This is often the most common areas for air leakage. So it's really those breaks in building envelope are causing the air leakage. And as far as addressing those air leakage, there's a couple rules of thumb. First is you're always supposed to start air sealing the attic first. These are the most significant leaks. In this case, you're actually now addressing where the air is being escaping from the building, particularly in the colder climates. Then you want to address your basement and crawl space. This would be your second priority. In this case, you're actually eliminating the source of the infiltration. And then you want to focus on the largest holes first within the conditioned space. This is really the best practice for addressing air leakage sealing within the home. So really, if you talk about weatherization, there are 4 key areas that we always try to focus on that you want to do as it relates to the house. First off is that you want to address the comfort of the home. Comfort's probably the biggest selling feature for air sealing. Reason being is that this is not related necessarily to dollars, but related to how the occupants are feeling inside the house. A perfect example that people will pay for comfort is typically if somebody feels uncomfortable in a house, it's too cold, it's too leaky, they do one of 2 things. Either they grab a blanket and or they go turn up their heater. And by turning up their heater, in effect, they are actually paying for increased comfort. So air sealing will actually have a dramatic impact on the comfort of the home by preventing some of those leakages and providing more consistent air temperature. Another component would be energy efficiency. In this case, it certainly would be trying to reduce your utility costs. It might also be if you're upgrading to new air conditioning or a new furnace. By air sealing your house, you can go with a more affordable, more energy efficient furnace, maybe sizing it properly for the house. The other component would be indoor air quality. And on this one, what we're really talking about is the ability to be able to keep the air inside your house more pure. If you have mold is typically a byproduct of air leakage, and mold obviously has some negative impact on the indoor air quality. So by air sealing, you prevent a lot of hot, moist air coming into the house or condensing within the housing structure. As a result, you're making the air inside that facility higher quality. And the last component would be improved structure. If you think about a house by itself is the single most largest investment that a homeowner would have. And the ability to be able to make that home a better home has a positive impact on resale value of that home, has a positive impact on longevity of that home as well. So really, if we look at this, weatherization equals 2 things. It would be first diagnostics, understanding the areas where the home needs addressing as far as air sealing would be concerned, and then the actual improvements on the home. Right now we're going to talk a little bit about the diagnostics and some of the tools that are commonly used in weatherization by contractors. First off, the most prevalent of anything would be the blower door. This is the most significant diagnostic tool. The blower door really allows a contractor to simulate a house under worst case conditions, and in this case, worst case conditions really might only be simulating similar to a 20-mile-per-hour wind hitting the house. So what they do is that they close all the windows and doors to the house on the exterior. They open up all the doors in the interior. Then they take a big fan and they basically suck all the air out of your house to the tune of 50 pascals. 50 pascals is a measurement of pressure, and that means that they have a very consistent pressure within that house. So if they go from house to house to house, they're depressurizing every house to the exact same pressure. It provides a great even playing field as far as being able to compare homes. And then what they can then do is measure your air exchanges per hour. The air exchanges per hour simply are how many times the air is completely replaced and replenished within a house on an hourly basis. This provides a measurement that then a contractor can determine how to address the problems within the home. They can measure after the work is being done, and it provides validation for both the contractor and the homeowner that the work that has been done has actually reduced the air leakage within the home. Another diagnostic tool is infrared imagery. This is great, particularly from a homeowner perspective, because it visually shows where there's problems within the home. If you look at the image on the left, on the top left, that actually is a hanging lamp or a hanging light fixture in a vaulted ceiling. And if you look below where it shows the infrared imagery, in this case, that electrical work and everything for that hanging light fixture is actually going right up into the attic. It has not been properly sealed, and where you can see the hot blue or the bright blue and bright purple, that means right there that you've got a lot colder temperature near that penetration going up into the attic, meaning that you're actually getting cold attic air while this house is being depressurized. It's pulling that cold attic air into the conditioned space. That's one of the prime areas that you'd want to be able to air seal. The image right next to that is actually showing a wall. In this case, it would be an exterior wall, and where you see again the blue or purple, most likely that would show that there's actually no insulation in that wall. An opportunity then again to be able to provide insulation and to air seal that up. Then the third picture is showing a great example where you have adjoining building materials, and those adjoining building materials have not been properly sealed. And again, you can see by the black or dark purple, that's much colder conditions. So as this house is being depressurized, it's actually pulling that cold air through the adjoining building materials. Again, it'd be a great area to be able to address for air sealing. Another diagnostic tool is a smoke pencil. What a smoke pencil does, it basically provides a puff of smoke that provides the visual effect of air being either sucked out or being blown away. So it shows a visual. Again, this is a great tool for the homeowner because it can actually help the homeowner see that you've got air movement happening throughout the home. Now, if you're in a very dramatic house with a lot of air leakage, it's just as simple as putting your hand down and you can feel the air leaking through a lot of these small penetrations. So those are some of the more common diagnostic tools that a contractor would use. He would use that in his own ability to be able to find the air leaks, but also to be able to share with the homeowner where the air leaks are coming from. So again, focusing on what is weatherization, the comfort, energy efficiency, indoor air quality, and improved structure. In indoor air quality, this is a great picture, great example of how indoor air quality could negatively be impacting a house. This is a crawl space, most likely a vented crawl space that had at one point in time insulation on the underside of the first floor. And what has happened in this case, I could imagine that this would be warm air coming in through the vented crawl space, most likely in a southern climate, and your air-conditioned first floor, as soon as that warm air hit the first floor, and that bottom of the first floor was cold because of the air conditioning, it then created condensation that eventually turned into lots and lots of mold. In this case right here, if you think about the stack effect, air could get pulled up into the house, and that provides obviously poor indoor air quality. You don't want those mold or mold spores to be entering inside of the house. Also related to indoor air quality, in this picture you can see this is actually a hot water tank. And what you see on the hot water tank here is charring, and this is where the combustible flame is actually being pulled outside of the hot water tank and charring the outside of the tank. What's happening here is, imagine a house is being depressurized due to the stack effect. This hot water tank is most likely down in the basement of the house, and what's happening is that the air is infiltrating from the basement and exfiltrating out of the attic, and that air movement is forcing the air from the basement to move up into the interior of the house. As a result, that movement or that depressurization is pulling the flame from the combustion flame, if you will, of this hot water tank, and it's pulling it out, and that's why you see charring on the outside. The issue that you have here is that combustible flame is creating carbon monoxide, and now creates a very dangerous indoor air quality problem that should be addressed, again, by addressing the air sealing of the home, reducing or eliminating that stack effect. Could have a dramatic impact on the proper functioning, I guess, if you will, of this hot water tank. As far as energy efficiency, I briefly had touched base on this. Very common trend right now within the heating, ventilation, and air conditioning industry is, prior to coming into a home and actually determining the size of furnace and or size of air conditioner that's needed, the first step should always be air sealing the home. Reason being is that when you air seal the home, you're now providing a much more efficient house that could handle potentially a smaller furnace. Smaller furnace means a lower investment, and a smaller furnace means that that furnace is going to be able to run at peak efficiency. If a furnace is continually cycling on and off and never getting a chance to hit its efficiency state, you're a 95% energy efficient furnace may be running at 75 to 80% just because that furnace isn't working properly within the home. So the consideration of the type of furnace that you want in a home really has to be tied very heavily to how tight the home is and how tight the building is. And again, as we said, improve structure. Anything that you do to your home, whether you put in granite countertops, whether you put in a new bathroom, the hope is that you're improving that structure, you're improving the value of the structure, you're improving the longevity of the structure. Air sealing is a great way to be able to assure that your home is going to be healthy and that it's going to be able to sustain the long term, particularly harsh winters, hot summers, and hopefully we'll have an improved structure that will be a lot easier to sell when the time comes. Now we want to focus on some common weatherization applications as it relates to the low pressure foams. Transmission and air leakage. This happens throughout the whole entire house. It happens in attics and roofs. It happens in floors and foundations. It happens in walls. It happens in windows. The trick here is air sealing. Air sealing with foam has by far the highest and the quickest return on investment of any other air sealing applications. This not only relates to the ability for foam to be able to fully expand and be able to fill up any of these voids, but it also relates to the fact that from a contractor's perspective, the install is much quicker than other types of applications or other types of products. So the question becomes, why use low pressure foam? First off, it's the absolute best product to stop air infiltration because foam inherently has an expansion characteristics, and as a result of that, that expansion helps fill irregular shapes in any of these penetrations or voids within a house. Secondly, it is a moisture barrier, so foam will prevent moisture from coming into a home. It does provide a thermal bridging. This is going to have a dramatic impact on your reduction of mold or mildew potential within the house. Thirdly, it also does reduce noise, so it will provide a tighter, quieter structure that you live in. Fourthly, it's an effective solution for tricky insulating problems. Foam, because it can be sprayed, it can reach areas that you might not be able to reach with typical caulk or other insulating products. And again, that expansion characteristic means that you can fill up an irregular void, and the expansion will help create an airtight seal. It's fifthly convenient for small retrofit jobs, and it's very easy to apply. And lastly, if polyurethane foam has the highest R value of any insulating material out in the marketplace, so if it's utilized in, for example, this picture here, a rim joist, if you spray 3 inches, you're going to get an R value of a little bit over 18 per that 3 inch. So the high R value also means that in many cases you can utilize this not as air sealing, but also as the core insulation. Now I want to talk about attics and how low-pressure polyurethane foam can be used for air sealing within attics. A couple different opportunities. We often refer to what's called critical seal. The critical seal is really focusing on the critical penetrations that are coming through the attic and addressing those, sealing those, utilizing foam. There's 2 different ways that you can do it with critical seal. We'll talk a little bit more in detail about both. One of them is utilizing it with existing insulation, meaning that you're not going to replace that insulation, but rather you're going to work around that insulation. This is by far the cheapest way to be able to do it from both from a material standpoint and in often cases from a labor standpoint. The other opportunity is still do the critical seal, but in this case replace the insulation and apply new insulation. This provides some opportunities to increase your R value if you're looking for that. Maybe that existing home is not quite up to code and you want to be able to bring it up to code as far as it relates to R value. Then the third that we're going to talk about is not critical sealing, but rather sealing the entire attic floor, what we would call more of a skim coat on the entire attic floor. This one provides a little bit more of a guarantee seal because in case you happen to miss a few critical seal points within the attic, the entire seal of the attic will make sure that that is not the case. So I want to talk about all three of those. First off, the critical seal with an existing insulation. What we're really talking about here is moving your existing insulation. It could be lifting the fiberglass backs. It could be raking back the loose fill fiberglass or cellulose and exposing the actual attic floor. After you expose it, you find the areas that need to be sealed. These typically will be areas like seams, thermal bypasses, top plates. It could be penetrations such as your plumbing and electrical penetrations. Most commonly, it could be recessed lighting. These are the areas that you want to take foam and you want to be able to seal and prevent any air seal coming from the second floor, first floor of the house coming up through the attic. You also want to be able to install baffles, and what the baffles allow is for the soffit and the ridge vent to be able to work properly, to be able to move air through the attic so that you prevent any moisture condensation, etc. In this case, you want to be able to actually take foam and make sure that you can air seal those baffles as well. And you certainly want to address any attic hatchways and make sure that the attic hatchway is sealed properly so you don't have air leakage coming from the, again, first or second floor coming up through the attic hatchway. Then you also want to look at the critical seal with new insulation. In this case, this would be completely removing the existing insulation. It could be that the insulation is old. It could be that you're looking for maybe newer technology, what have you. In this case, you would actually remove the insulation, and then you would critical seal again with foam. A little bit easier because now everything's going to be exposed. You're going to see all the areas that you need to be able to utilize foam, such as the seams, penetrations, recessed lightings. You're still going to want to install baffles. And then you want to come back and insulate with insulation again. It could be loose fill insulation, fiberglass, cellulose. It could be bats potentially. What this could allow you to do is that if you want to increase your R value from what you had before, this allows you to be able to do that by putting the right amount of loose fill insulation or fiberglass bats in. Again, still want to also address and seal the attic hatchway. Sealing the attic floor with new insulation. In this case, we're not talking about critical sealing, but what we're talking about is removing the existing insulation. You want to install baffles at the eaves. Then you want to spray the whole entire attic floor with 1 inch of foam, including up to the baffles. So in essence, you're completely capping off the attic floor. You want to pay special attention to, again, the same areas, penetrations, recessed lighting, electrical conduit, things like that. Then you want to be able to backfill with whatever R value. In this case, if you're not comfortable, or in some cases you may have so many penetrations that a critical seal just may not make as much sense, you feel much more comfortable going in with an entire 1 inch over the foam. You're creating, in essence, a hybrid insulation, and you're offering, again, stopping all that air infiltration or exfiltration out of the house. Knee walls. Knee walls are often overlooked within a house. You want to address this in a very similar fashion. You want to remove your existing insulation. You want to either perform a critical seal behind the knee walls, or you want to apply 1 inch of foam on the back of the knee wall as well as the floor. And then you want to insulate with loose fill or bats to reach the required R value. The rim joist, again, now focusing on the area where foam not escapes but rather enters into the home. The most problematic area is your rim joist. Most problematic for two things. One is that a rim joist is a thermal bridge, so you have propensity for water condensation as well as air leakage coming through. What foam does in this case, if you remove your existing insulation, which would typically be fiberglass bats, and if you apply a 1/2 inch to 1 inch of foam, what you've now created in essence is a thermal and an air barrier. You can then take in a retrofit application, existing fiberglass bats, put them right back in place, or you could just foam 3 inches or more of foam, or whatever the code requires for R value in that rim joist. And if you need to be able to cover it back up with ignition barrier, you could do so, or you could just keep it exposed. We're now going to talk a little bit about a vented crawl space. A vented crawl space can create some problematic areas, typically in that one picture that we showed, if the venting is not working properly, meaning that the moisture that's entering into the crawl space is not properly being exited from the crawl space. And in the picture that we showed, where the moisture was then condensing on the underside of the first floor, it created mold and mildew issues. In the case of a vented crawl space, one opportunity or application is to turn that into an unvented or conditioned crawl space. In that application, what you want to do is you want to cover and seal all the vents. Then you want to apply a vapor barrier wrap over the walls and the floor, and you want to bring that up on the walls to the rim joist. And then you want to spray the rim joists at least an inch along the top of the wall and down to the floor of the crawl space. So in essence, you are insulating you're insulating the walls just like you'd be insulating the walls of the home, because this now is a conditioned crawl space. You need to have some insulation in there. And as code would require with polyurethane foam, you'd probably want to be able to put some form of an ignition barrier, which could be an ignition barrier type paint, or even a other type of barrier, depending on what code would require. An alternative method could be to not condition the crawl space, keep it vented, but rather spray foam, about 3 inches of foam on the underside of the first floor, completely air sealing and encapsulating the floor and the rim joist. So in essence, you are keeping the crawl space as a vented crawl space just like it was, but you're preventing any problems in that crawl space from migrating up into the first floor. In essence, you're capping off the crawl space so that first floor and the crawl space are not tied together anymore. This is a picture right here that you can see the white vapor barrier wrap that they've brought up to the rim joist, and in this case they're insulating the rim joist, and then they're starting to insulate down the side of that vapor barrier wrap. They will eventually insulate all the way down the vapor barrier wrap until the vapor barrier turns into the floor. Some considerations that you have to think about if you today have a crawl space that houses your plumbing and various HVAC components. It might be where you have your furnace downstairs. You might want to consider doing a vented or an unvented crawl space, a conditioned crawl space, because you would have the equipment down there that you would want to make sure is not going to be, I guess, hit by the elements. In the case that you see of this picture right here, you see that you've got your HVAC unit, your furnace unit down below, and you've got looks like mold and mildew up on the top of the crawl space. So that's actually pulling air from the crawl space up into the living conditions, again providing poor indoor air quality. Beneath porches, this is an area that's commonly overlooked. This would be protrusions or rooms under porches, often lack sufficient insulation. What you want to do in this case is remove any existing insulation, apply 3 inches of foam overhead, and top a couple feet of the wall. So again, you're in essence creating an air barrier, and you're preventing any air from infiltrating in from underneath the porch that could then enter into the home and escape out through the attic. Bay windows and cantilever floors. Oftentimes these are not accessible from the inside. However, it can infiltrate through the underside or the soffit of the house. So here you want to be able to figure out how to access that. Most likely it would be accessing it from underneath the outside. Spray 3 inches of foam on the underside and then reattach the soffit. Awning above bay windows, as this picture is showing here, this is often another area that's overlooked. In this case, it would be easier to access from the inside. You'd probably have to cut away the drywall, expose a few holes to allow access, and then see if you can't spray foam. And if it's a big enough hole, you can add some fiberglass and then repair the drywall. A little bit invasive, but these can often be major areas for air leakage and discomfort within the home, so well worth the investment. Windows. If you're talking about existing home, replacement windows, there's a lot of folks that are trying to sell replacement windows to add increased comfort. In many cases that could be the case, but the issue is that they often do not improve the home's energy efficiency to the dramatic tune of major dollar savings. And if you look at it from a return on investment, the energy savings that you might save, it will take years upon years to recoup the cost of those replacement windows. What you can do to improve any window, even if it's an existing window, to make the comfort of those windows better is to air seal around those windows. In this case, you would want to remove interior trim of the window, install foam around the perimeter of the window. That would be where the window, between the window and the actual stud of the wall, reattach the trim, and if need, repair any glazing. Most air leakage around windows does not come obviously through the window itself, but the actual air leakage comes from around the windows. In this case, you'd be able to address those issues. Now I want to talk about weatherization case studies that we've done as it relates to our foam products being used for air sealing. We did one home, as you can see down below, that was 2,300 square feet. This house, we determined according to the ASHRAE standard that the minimum ventilation requirement was 5.4 air exchanges per hour at 50 pascals. This number became the target that we wanted to achieve for the house. Then we did an actual blower door test under the same conditions, air exchanges per hour at 50 pascals, and determined that the current air exchanges per hour was 9.3. So we're at 9.3. Our goal is to get to 5.4. What that proved to us is that we had plenty of room to be able to stop the air leaks within the home. In this house, we had an attic, so we did the thing that we were supposed to do first, which was address the holes within the attic. In this scenario, we actually removed all the cellulose insulation, had an exposed attic floor, and did 1 inch of polyurethane foam across the entire floor, and then replaced with new cellulose insulation. We then did a blower door test and determined that we reduced the air exchanges per hour from 9.3 to 7.0, which was a 25% reduction. We then followed up with the rim joist, and we did an inch of foam within the rim joist, and then backfilled with the fiberglass insulation that was already there, and did another blower door test with the combination of the two foam treatments, and achieved a 6.3. So we went from 9.3 to 6.3 and achieved a 32% reduction in the air exchanges per hour, a pretty dramatic impact just by the use of foam. The second home that we did was 2,500 square feet. In this case, a little bit larger home, and we determined that the minimum ventilation requirement again was still 5.4 air exchanges per hour at 50 pascals. And our initial blower door test determined that we were at 10.4 air exchanges per hour. So again, 10.4, our target was 5.4, a much more dramatic opportunity for us within this home. And in this case, the home had a cathedral ceiling and really no access to the attic because the cathedral ceiling was only about a foot between the ceiling and the actual roof of the house. So we first decided to address the rim joist. In this case, we did initial foam in the rim joist, did a blower door test, and we reduced it from 10.4 to 8.8 or 15%. Then we looked and realized that there was a cantilevered floor that was causing a lot of air leakage. We went on the outside of the cantilevered floor, was able to spray 3 inches of foam underneath the floor. It was about 100 square foot of area. Did another blower door test, and that dramatically reduced it from 6.6 was our test, down from 10.4 or 37% reduction. So both of these scenarios got us over 30% reduction in air exchanges per hour. That will translate to improved comfort in the home, improved quality of the home, or improved structure, as well as will result in better utility costs as these houses move forward. Now I want to address a little bit about the safety during application. These products are professional products, as we had mentioned. They're intended for professional use only. They are also chemical products, and just like many other chemical products, they have special personal protective equipment or PPE requirements for these products. Looking at the first column, this is what we call one-component foam. This is a typical sealant that would be applied either by a straw or a gun. It'd be a product that you would find through professional distribution or through retail. And when installing this product, the requirement would be safety glasses. You want to make sure that your skin is covered as well as your hands with nitrile gloves. You want to make sure that you're going to apply the foam where you have proper ventilation. Now, if you look at the other two columns, these would be the two-component polyurethane, spray polyurethane foam low-pressure products. One of them in disposable packaging, one in refillable. Same technology, same chemical makeup. And during application of both these, the required PPE, again, would be protective eyewear. You want to cover your skin. You want to have nitrile gloves for your hands. And in this case, you want to use organic vapor respirators and make sure that you've got proper ventilation when you're installing. These are all very important recommendations that we want to see happen as far as utilizing these products in applications, particularly as it relates to the weatherization applications that we're talking about today. That concludes the webinar. If anybody has any further questions about these applications or about the products that are offered by Fomo, you can visit Fomo's website at www.fomo.com or email Fomo at info@fomo.com. Thank you very much.